Welcome, ladies and gentlemen. Mr. Clemmer's here with me today. He's going to be recording some stuff. Obviously, I have a camera on my head, but we're doing this to try to help you understand the dissection of the eyeball a little bit better. So you got a little close-up view here. We can kind of get things going so we don't have to spend as much time in class on this. So make sure that you're watching this and taking notes, because you're going to have to show your notes and your directions to me before you walk in the door to make sure that you can do this in class. So first things first is on your scalpel, this blade should be fresh. You have to cut through so much muscle and fat that if you have anything less than a brand new blade, this is going to be really hard and take a really long time. The other thing we have is dissection scissors. So the dissection scissors are going to be important when you get down to the sclera, and we're going to have to do some cutting on the eyeball itself. So you're going to need those as well. The eyes that we have a ton of extra stuff on them, and a lot of people get afraid sometimes of cutting into the eye, so they're really delicate and they take a really long time cutting all of this chunks off. All right, but all of this stuff, all the white is the fat, and all of the darker gray, or sometimes if you get in deep enough it might even still be red, this is all the muscle. There's a ton of stuff here that needs to come off, but this is the one thing that does not come off. This is your optic nerve. It's hard, it's almost like a little twig. This needs to stay on, and this is going to be a guide for you. You're going to kind of follow the optic nerve down to get to the back of the eyeball. So if you look at it, this is the front, and it's really only just a sphere that's about that wide. So you see that there is a ton of stuff that needs to come off. So without further ado, let's get to cutting. So I'm going to start with a scalpel, and I'm going to work my way down the optic nerve. I have the optic nerve here. So I'm going to start there and kind of cut my way out. My scalpel, I want to make sure I have a good hold on the scalpel. And I'm going to go ahead and cut down. And because this is a fresh blade, it cuts through pretty easily. You can see that this is all just the fat and the muscle. So we have to do this cut a couple times. And get down even further. Still the exact same stuff. There's a lot of distance to get to before we get to the eye here. This cut though, I'm going to be a little bit more careful just to make sure everything, the depth isn't too deep. I'm applying a little bit of outward pressure here with my fingers. I'm doing like a reverse pinch here to help expose everything, and then I'm being very delicate with the drawing of the fresh scalpel blade through all the material. And then I'm going to get down to the eye. This is going to be the sclera, so it can be something you accidentally cut into if you're a little bit too indelicate. So if you see right down this crease, my optic nerve is at the end, and then here is the sclera. I still have a lot of fat to remove, and I got to cut it around the outside, but that's the depth that we're trying to get to. So I'm going to use the scalpel and kind of work my way around the outside of the eye. I'm almost just like I'm peeling an orange, just going to be removing, gently applying pressure and just removing all this fat and muscle into one piece. So you see, this is the chunk in my left hand that I've removed so far, and I'm going to keep working on this. I'm going to keep coming around all the way around the outside of the eye. And it doesn't have to stay in one piece. It's okay if it comes off in chunks. If you have a eye that's a little bit tough or has more muscle, or your scalpel blade isn't exactly fresh, this would be nowhere near as easy to remove. So I'm going to go ahead and remove this chunk just to get it out of the way. Again, nothing but fat and muscle here. This is obviously very important for your eye to function, to be able to move things around, but for our purposes, we are done with it. So we're going to get it out of the way. always keep an eye and make sure that you know where the optic nerve is. You don't want to cut it away, and it's going to be a nice, helpful guide for you to cut with. And you notice as you get close towards the end, down to just the sclera, that you start to see what is normally white in your eye is going to be this darker gray, but it doesn't have that same texture that the muscle tissue did. So this is how you know that you're down to the scleras. You might have that same color, but you don't see this steak-ish muscular tissue here. So you're going to try to clean this up a little bit. I still have a couple chunks on there, but this is the depth that I'm getting to. So I'm going to go ahead and remove these last couple chunks of muscle and connective tissue. So you see, all of the, for our purposes, waste products actually make up probably kind of more of the volume of our original specimen than the eye that we're actually looking at. But removing all of that gets what we're looking for. The optic nerve is still connected to the back of the eye, but our eye is intact. Depending on the freshness of your eye and the integrity of your eye, it might be more pressurized or less pressurized than this one. You see that the normal shape of your eye is going to be a little bit of a higher pressure situation. It's a bit more rounded like you're used to, but as you see as I squeeze this, there's going to be a little bit of juice that's coming out, a little bit of the vitreous or aqueous humor is coming out, just because of the integrity of the eye of this being stored for so long. So it's not going to be quite as high pressure as you're used to if you in your own eye. But now that we have our specimen ready, the big thing really is that you need to make sure that you have an open area around the sclera that's kind of like the hemisphere that separates the anterior portion and the posterior portion. That's what you're going to be cutting along with your scissors. So you want to make sure that all the musculature and any fat is out of that line of cut. So I'm going to take my scalpel and I'm just going to use this to make a tiny incision on the side of the eye. Light is going to come in this side of the eye and it's going to go towards the retina. We're going to cut through that line. So you're just going to do a little cut on the sclera on the outside. It's probably best to angle this cut away from you so it's not pointing at you, and make sure your mouth is closed during this. You can ask me later, but there was a pretty nice incident where someone had their mouth open during the cut. You can imagine what's going to happen. Apply a little bit of pressure to your eye and then make this cut. It just has to be small, just big enough to be able to fit the dissection scissors into. You're going to put your scissors into that cut and then try to maintain that line and cut through the eye all the way around. So you're going to do a hemisphere cut. And so what you'll end up with is almost like a little cup with a stem here, and then all of that material in the back, that kind of wispy light material that kind of floats around, is your retina. So you got to be very careful with the back half of the eye because you can rip that very easily. I'm going to set that to the side for a second. This is the anterior portion of the eye, and you see in here is the lens, which is this hard marble, and then in both sides you have this jelly-like substance. So I'm going to go ahead and remove the lens and this jelly material. This jelly is called vitreous humor, and it's basically it's a protein water solution. You see it kind of jiggles around, and it's what helps kind of give your eyeball its structure and kind of helps keep the retina in its place. And this lens is what actually does the focusing, just like the lens in a camera. This one is cloudy and hard compared to what it would be naturally because of the preservative in the preservation process. But normally you should be able to see through it. This one's kind of opaque. You can see that there's something on the other side, but there's no real clarity to be able to read something through it like you could with a fresh eyeball. It would work as a magnifying glass. So I'm going to go ahead and remove the rest of this vitreous humor that's up here, because the next thing we're going to get to is the iris. So in a cow, the iris is actually kind of an oval, rectangular-ish structure, as opposed to the humans, which is going to be circular. But then you see inside, I'm going to flip this inside out, you can see around the outside of the opening all these lines which are angled in a circular manner pointing towards the pupil. This is actually kind of the musculature that allows the pupil to open. Take your thumbnail and get up underneath of that muscle, and you're just going to peel this out. And again, just like a sticker, you're going to separate these two. And so this is all the musculature all by itself. And you see very easily that this is a kind of a oval rectangle or rectangle with rounded corners. And then what's left up front is the cornea. And so if you listen closely, I'm going to put my scalpel blade through the cornea, and you can hear it crunching as it goes through all the different layers, because the cornea has multiple layers to it. And when you go get certain types of eye surgery, corrective surgery, they just shave parts of the cornea off to allow light to go through it better. But listen closely. If you could hear that, it sounds almost like celery kind of, as it kind of crunches through multiple different pieces. The other thing with the eye, the back half of the eye, is actually where light gets detected. The front half of the eye is all about organizing the light, and the back half is all about collecting it, and the brain is all about analyzing it. So very delicately, I'm going to try to remove and kind of dump out the rest of the vitreous humor. We didn't get to see it in the front, but the material in between the lens and the cornea is the aqueous humor, but since our eye had leaked a little bit, we didn't really have much. I want to be able to dangle the retina from its attachment point. And so my cut was a little bit too anterior for you to see this easily, so I'm going to go ahead and cut back some of this. The retina dangles from one place on the back of the eye. There's still a little bit of vitreous humor clinging to that. I don't want to tear it, so I'm not going to remove it. But this is all, this network of cells is actually attached to one point. If you follow the line, it's actually attached to the same place that the optic nerve is attached to. Because the retina is actually just the end of the optic nerve. It just spreads out, almost like roots in a tree. The retina is spread across the back of the eye. But there's nothing actually attaching it to this blue turquoise background. There's nothing that actually physically attaches it. It's just held by pressure up against it. The blue surface is called the tapetum, which is something that you're not going to see in the human eye. It's something that will be in various animals, and then if you've ever shined a light into the forest and seen eyes looking back at you, just two glowing dots, it's because of the tapetum or something, a similar structure in an animal bouncing that light back. But that retina is very gently, very delicately attached to the optic nerve at the optic disc. And you can see just a gentle tear a slight pull is going to pull off chunks of retina because it's a very, very delicate structure, just a couple cells thick. Next time you're in class, you will be doing this dissection. So again, make sure if you didn't understand something or you didn't pay attention at some part, you rewatch this video, and I'm expecting you to come in with your directions all written, ready to go, and you're ready to sit down, collect your materials, and start dissecting this eye.